liquid nitrogen in the beaker, and I want you to describe to them what it looks like it's doing.
Looks like it's boiling.
Yes, because it is. You know, most of us, of course, the only thing we've ever seen boil in our lives is water. And water boils at 212 above 0 Fahrenheit. This boils at 320 below 0 Fahrenheit. Looks hot, it definitely isn't. It's sucking energy out of the tabletop and the air in order to make it boil. And Tori, I want you to trust me on this. Convince yourself that the gas coming off really isn't hot. Once you take your hand, I want you to stick it in the beaker, just don't touch the liquid. Even if she does, she won't do it for very long. Okay, good. And you can definitely feel that it's cold. What's the smoke coming out? Anybody know? It's not nitrogen. We know nitrogen's colorless because 80% of the air is nitrogen.
Water.
It's water. And so if there's a humidity in the air, it's cold enough to cause it to condense, so that the smoke that you see is just water vapor. We're going to do a couple of experiments to show everybody how cold this is. All right, we're going to take the balloon. And this is a really important aspect of thinking like a molecule here. So we've got a balloon, and we know the molecules are banging around and they're trying to get out. I'm going to have you grab this, and I'm going to help you with this experiment. If you haven't done before, it's creepy, but you're not going to get hurt or anything. And I'm going to take your hand and we're going to lower it into the beaker. I want you guys to think about what's going to happen. So the molecules are going to start to slow down as they get cooler, slowing down so they're not hitting the balloon as hard anymore, so you're not getting as much pressure. So the outside pressure now is causing the balloon to collapse because the molecules are not moving very fast. But if we take it out, they'll start to move faster and faster and faster, and it'll just come back to normal. All right? We'll lower it into there again. I'd like you to just let go of it. Now, this should give you a physical chemist's perception of temperature. All temperature is, it's a measure of molecular motion, right? On a cold day, molecules are moving slower, not hitting you as hard, not giving you as much energy. You perceive that as being cold. Hot day like now, they're moving a lot faster on average, and so you perceive that as being warm. Now, one thing you got to be careful about when you're designing, like the shuttle main engines, when you have these cryogenic systems, are what you use for gaskets, what you use for sealants on things. Latex rubber is not a very good choice. All right, you'll see why. Because it's pretty brittle at those temperatures. So you got to really think about what it is that you're going to use when you put all the materials together, certainly from a chemistry perspective. I'd like you to pick somebody to help you.
Oh, great. What am I doing now?
We're going to do this one just because it's fun, all right? And you're going to need, both of you are going to need your hands here. And Jordan, can I just stand over there? Right there. And I need you to put these on. All right. And Tori, if you feel that, nice and soft. Carnation petals nice and soft, almost all water. You know, you touch your skin, soft for the same reason, almost all water. You're going to see what it does to the water in here at 320 below for 3 seconds. And so I want you to hold it like that. You and I, we're going to hold it into there for 3 seconds. We're going to take it out. We're going to shake it off. We're going to hold it over the paper towel. And when I tell you to clap it, Jordan, right on the flower, clap it and then let go. Feel it one more time so I can feel like that anymore. 1 1,000. 2 1,000, 3 1,000. Clap it. And of course the consistency is a lot different now, so it's really hard as a rock. It feels like glass because it's so thin and everything, but nicely done, made a nice mess too. So I think they deserve an applause. They both did a nice job on this. Now, you gotta ask yourself, well, why? You gotta go